beginner, look at a photograph of Earth taken from orbit. The astronauts who take these pictures always describe the same feeling: silence, stillness, a kind of peace that words struggle to capture. And when we see those images down here, safe on solid ground, we absorb that same feeling secondhand. Space looks calm. Space looks like the gentlest place in the universe, a quiet black ocean scattered with light. I need to tell you that this feeling, as beautiful as it is one of the most dangerous illusions we carry about the cosmos. Throughout my career, I have studied the razor-thin margins that separate a living human body from a dead one the moment it leaves this planet's protection. And the closer I look, the more I realize that space is not calm at all. It is one of the most relentlessly hostile environments a human being has ever deliberately chosen to enter. And it is dangerous in ways that have very little to do with the alien monsters or flying debris we usually imagine. Today, we are going to walk through exactly how dangerous space truly is. And if you want to keep exploring the honest, unfiltered physics of survival beyond our atmosphere with me, make sure you are subscribed, because some of what we are about to cover, astronauts themselves rank as more frightening than almost anything else they train for. Let us begin with the most basic fact of all, the one hiding beneath everything else. Your body, right now, is being held together by pressure. 14.7 pounds pressing on every square inch of you, an invisible hand keeping your fluids where they belong. The moment you leave that pressure behind, unprotected, your body has no idea what to do with itself. Imagine a diver who ascends from the deep too quickly, and think of that danger in reverse. Then multiply it by a universe of nothing pressing back at all. Without a suit, a human exposed to the vacuum of space would not explode, as the movies love to suggest. But within about 9 to 12 seconds, consciousness would fade as blood stops carrying oxygen where it is needed. Within moments after that, bodily fluids would begin to vaporize under the pressure difference, a process called ebulism, not because space is hot, but because there is nothing left to hold your own body's chemistry in place. Death would follow within minutes, with no possibility of self-rescue, no time to think, no time to react. NASA engineers know this with unsettling precision because a handful of accidental depressurization incidents in ground testing chambers have given us real data, real survivors, real timelines. The lesson from every single one of those incidents is the same. Space does not negotiate. It does not wait for you to notice your mistake. But the vacuum itself is only the beginning. Beyond it lies something quieter, something invisible, something that never announces itself at all. Radiation. Here on Earth, we live wrapped in two enormous shields we almost never think about: a thick blanket of atmosphere and a magnetic field generated by a molten iron heart spinning far beneath our feet. Together, they deflect the overwhelming majority of the radiation constantly pouring toward us from the sun and from the violent deaths of distant stars across the galaxy. Step beyond that shield, and you step into a storm that never stops. Astronauts aboard the International Space Station, who still sit partially inside Earth's protective magnetic field, absorb radiation at roughly 100 times the rate of someone standing on the ground beneath them, or travel toward the moon or toward Mars, and that exposure climbs even further, with almost nothing standing between your body and deep space radiation except the thin metal walls of your own spacecraft. Think of a lone traveler crossing an open desert beneath a relentless sun with no shade for 1,000 miles. Every hour beneath that sun quietly, invisibly costs something, a toll paid not all at once, but cell by cell, year by year, long after the journey has ended. That is what cosmic radiation does to the human body across a long mission, raising cancer risk, potentially affecting the nervous system in ways researchers are still working to fully understand, all without a single warning sign along the way. And then there is a danger that surprises almost everyone the first time they hear it. Not radiation, not vacuum, something almost embarrassingly small, grains of rock and metal, some no larger than a fleck of paint, moving through orbit at unimaginable speed. Natural micrometeoroids can travel at 45 miles per second. Human-made debris, the leftover fragments of old satellites and rocket stages, orbits at roughly 17,500 miles per hour. At those speeds, size stops mattering the way it does down here. A fragment smaller than a coin carries enough energy to punch through a spacecraft hull or crack a window, which has actually happened aboard the space station, from debris too small to have ever been tracked in advance. NASA currently tracks more than 27,000 pieces of debris larger than a softball and untold millions of smaller fragments too tiny to follow individually. In 1978, a scientist named Donald Kessler described a nightmare scenario now known by his name, the Kessler syndrome. A chain reaction where every collision creates more debris, which causes more collisions, until entire regions of orbit become a minefield too dangerous to safely pass through at all. Picture a quiet highway that, without anyone quite noticing, slowly filled with invisible shards of broken glass, scattered by every accident that ever happened there before, each fragment waiting patiently for the next car that never sees it coming. That is what certain orbits around our own planet are quietly becoming right now while we speak. Even temperature itself turns hostile out there. Without an atmosphere to spread warmth evenly, a surface facing the sun can reach 250 degrees Fahrenheit, while a surface just a few feet away, sitting in shadow, can plunge to nearly 250 degrees below zero. Spacecraft and spacesuits are forced to endure both extremes within a single 90-minute orbit, expanding and contracting again and again, mission after mission, with failure never more than one flawed seal away. And history has already shown us again and again exactly what happens when these dangers are underestimated. In 1967, the crew of Apollo 1, Gus Grissom, Ed White, and Roger Chaffee, died in a cabin fire during a routine ground test, when a spark in a pure oxygen environment became an inferno within seconds. In 1971, the crew of Soyuz 11 died when a faulty valve allowed their capsule to lose pressure during re-entry, the only human beings in history confirmed to have died directly from exposure to the vacuum of space itself. The Challenger disaster in 1986 and the Columbia disaster in 2003 each claimed 7 lives, both traced back not to some exotic cosmic threat, but to a failed seal and a damaged tile. Small, almost mundane failures, amplified into catastrophe by an environment that offers absolutely no room for error. We have built such a peaceful, romantic image of the black silence above us. But underneath that silence is a vacuum that kills in seconds, radiation that accumulates in silence for years, debris fields turning our own orbit into a quiet minefield, and a temperature swing violent enough to shatter anything built without extraordinary care. And I've not even told you yet about the dangers waiting inside the spacecraft itself, or the slow, invisible toll space takes on the human body over months at a time. That is where we are headed next. Stay with me, because the most frightening part of this story is not what is outside the window. It is what begins to happen once you are already inside and already committed, with no way back for months or years to come. In the first part of this journey, we walk through the dangers waiting just outside the hull, the vacuum, the radiation, the debris moving faster than a rifle bullet, the violent swings between fire and ice. But I promised you the most unsettling part of this story was still ahead. Now we step inside the spacecraft itself and inside the human body, where the dangers grow quieter, slower, and in some ways far more disturbing. Let me start with something most people never think to fear in space. Fire. It sounds almost backwards, doesn't it? A vacuum with no oxygen at all, and yet fire remains one of the threats astronauts fear most, more in many cases than the vacuum itself. Picture a candle burning inside a sealed glass jar. On Earth, warm air rises, carries smoke upward and away, and the flame behaves in a way we instinctively understand. Now imagine that same candle burning inside a spacecraft, where there is no up, no down, no rising heat to carry the smoke anywhere at all. In February of 1997, aboard the Russian space station Mir, a malfunctioning oxygen-generating canister ignited a real fire, filling the station with thick smoke within moments and for a terrifying stretch of time, blocking the crew's path to one of their only 2 escape capsules. Had the situation worsened even slightly, half the crew could have been left with no way out at all. Fire in microgravity does not behave the way fire behaves here. It spreads sideways in strange, flattened patterns because there is no convection to carry it in a predictable direction. It is quieter, stranger, and in an enclosed, capsule-breathing, recycled air, one of the fastest ways an ordinary day in space can become a fight for survival. And when something does go seriously wrong, there is rarely anyone coming to help. On Earth, if critical equipment fails, rescue is usually hours away at most. In space, particularly far from home, that comfort simply disappears. In 1970, an oxygen tank aboard Apollo 13 exploded roughly 200,000 miles from Earth, and the crew survived only because they were able to turn their lunar lander into an improvised lifeboat, stretching every system, every calculation, every ounce of ingenuity to its absolute limit. There was no rescue ship waiting nearby. There was only the crew, the spacecraft, and the unforgiving mathematics of trajectory and oxygen. Picture a lone sailor 1,000 miles from the nearest port, discovering a crack in the hull of their ship. On the ocean, at least there is a chance, however slim, of another vessel passing by. In deep space, there is no passing vessel. There is no coastline waiting on the horizon. There is only whatever redundancy, whatever spare parts, whatever human cleverness the crew happened to bring along with them before they left. But some of the deadliest dangers in space never announce themselves as an emergency at all. They arrive slowly, quietly, one day at a time, hidden inside the human body itself. Without gravity constantly pulling against it, the human skeleton begins to dissolve, in a sense, losing bone density at a rate of roughly 1 to 1.5% every single month. A pace of decay that would take an entire year to match here on Earth through ordinary aging. Muscles weaken in the same quiet way, which is why astronauts aboard the space station spend up to 2.5 hours a day in grueling exercise, not to build strength, but simply to slow how quickly their bodies are being unmade by the absence of weight. There is a newer danger, too, one researchers are still working to fully understand. Fluid inside the body drifts upward in microgravity, settling around the head and the eyes in ways it never would under gravity's pull. Over months, this can reshape the eye itself, swell the optic nerve, and in some astronauts cause vision changes that never fully reverse, even long after returning home. NASA now considers this one of the single greatest unresolved risks standing between us and a real extended mission to Mars. And then there is the danger that has nothing to do with radiation or bone density at all, the danger of the mind itself. Picture a small group of people sealed together in a space smaller than most apartments for months, sometimes years, with no ability to simply step outside, breathe fresh air, or put real distance between themselves and a disagreement. Communication with home, once you travel far enough, stretches into a delay of many minutes each direction, meaning even a simple conversation becomes a slow exchange of messages sent into silence, waiting for a reply that might not arrive for half an hour. NASA has studied this extensively through real missions and through simulated isolation experiments in places like Antarctica and remote volcanic terrain in Hawaii. The findings are consistent. Isolation this complete, this sustained, produces genuine psychological strain, sleep disruption, friction between crewmates, and a weight that grows heavier the longer the mission stretches on, with no real precedent for what several years of this might eventually do to the human mind. Now, let me give you the numbers because I think they deserve to be said plainly. Of the roughly 600 human beings who have traveled to space since 1961, 20 have died in the course of that work, a fatality rate higher, mission for mission, than almost any other profession human beings have ever chosen to pursue, including deep-sea diving and mountaineering on the most dangerous peaks on Earth. And yet, we keep going. Astronauts themselves, almost without exception, describe the risk as worth it. Many speak of something called the overview effect, the profound, almost overwhelming shift in perspective that comes from actually seeing our entire planet hanging alone in the dark, fragile, borderless, impossibly small against the vastness surrounding it. It is, by nearly every account, one of the most transformative experiences a human being can have. So let me leave you with the image I keep returning to myself. Every single person who has ever left this planet has done so wrapped only in engineering and courage, crossing a threshold where the vacuum wants to empty their lungs in seconds, where radiation wants to unravel their cells across years, where fire behaves like something almost alien, and where their own skeleton quietly begins to dissolve the moment gravity lets go. And still, we keep building the ships. We keep training the crews. We keep reaching upward into a place that offers no mercy and no guarantee of return. That is not recklessness. I think it might be one of the most human things we have ever done, choosing again and again to walk directly into danger, not despite how dangerous it is, but because of what waits to be understood on the other side of it. Exploring these honest, uncomfortable truths about our universe is exactly why I do this work, and exactly why I wanted to walk through this particular journey with you. If this changed the way you look at that quiet, peaceful photograph of Earth from orbit, if it left you with a little more respect for everyone who has ever crossed that boundary, then make sure you are subscribed so we can keep exploring these questions together. Tell me in the comments, honestly, knowing everything we just walked through, would space still call to you? Until next time, keep looking up and keep asking what it actually costs to get there.